Welcome to our exploration of germanium, a key player in the realm of electronics. Today we delve into its pivotal role and lasting impact on technology. Germanium transistors had their advantages and disadvantages. It's also examined their modern applications in high-speed and high-frequency electronics, which showcasing how germanium continues to influence advancements in technology. Also can make combination of germanium with silicon in advanced semiconductor technologies, which has truly been a game changer. For a bit of background, the discovery and development of the transistor absolutely revolutionized electronics. This breakthrough led to miniaturization and enhancement of electronic devices, transforming the way we interact with technology. Germanium was the material of choice for the first transistor due to its advantageous electrical properties. This crucial development was made by Bell Labs in 1947. Germanium transistors enabled the creation of early radios, computer and other electronic devices, marking the beginning of a new era in technology. Germanium has good electrical properties which have a smaller bandgap, about 0.68 electron volts, compared to silicon, which is 1.12 electron volts. This allows it to conduct electricity more easily at lower voltage. Also, germanium transistors are highly efficient due to low voltage application. Additionally, germanium has higher electron mobility than silicon, which translates to faster transistor switching speeds, crucial for early high-speed electronic devices. This is data for transistor material against temperature. Can be seen that the higher temperature can reduce the value of EV, and the lowest EV is germanium material. For application of germanium got two parts, which is silicon germanium and Optoelectronic technology. Also on silicon germanium technology got two parts, which is HBT and CMOS technology. A heterojunction bipolar transistor is a type of bipolar junction transistor that uses different semiconductor material for emitter and base regions. This improves performance by enhancing electron mobility, which resulted in high speed and efficiency. Also commonly used in high frequency and high speed applications like radio frequency and microwave. This is a basic energy band gap. The upper line is the conduction band. Lower line is the valence band. Between both lines there was an energy gap. Based on the valence band, got holes and electrons. Then the electron is going to travel to the conduction band. Electrons reach the conduction band because of the small energy gap, which use silicon and germanium material. Silicon got 1.12 electron volts and germanium got 0.66 electron volts for the energy gap. Then, let's take a look at the energy bandgap for heterojunction bipolar transistors. The upper line is still the conduction band and lower line is the valence band. Now, let's divide it into three parts. This structure uses the NPN junction system. N-type uses silicon and P-type uses silicon germanium. Emitter placement on the left N-type, base placement on the middle, and collector junction on right position N-type. Next there is a hole diffusion from base to emitter. Electrons that already reach the conduction band on the emitter, gonna move to the base junction. Then the electron is gonna be collected at the collector terminal. Silicon germanium can enhance CMOS technology by providing higher electron mobility, fast switching speed and improved performance in digital and analog circuits. CMOS technology uses NMOS pull-down network and PMOS pull-up network to realize various logic functions. This design has a matching characteristic on switching on and off state. There is an advantage for CMOS technology, which is low power consumption in static condition and consume power when operated for switching. Also easy to design different logic functions. More compact and become a miniature size. The speed and power are not affected when the size of the transistor is downscaling. This makes CMOS technology is widely used in analog IC and mixed signal design. For optoelectronics more to lighting devices, which is light-emitting diode LED. This is basic for creating light. When electrons combine with holes, light will be created and emitted through the PN junction. Let's proceed to the next part. This is the layer structure for the LED. Got three layers. The P-type layer contains a lot of holes. The PN junction. The N-type layer contains many electrons. Now let's add a battery. The supply is gonna make electrons move to the P-type layer, which makes the electron attract to the hole charge. When a combination of electrons with holes happen, light will be created and emitted on the PN junction. That's how the LED works.